Okay. So today we'll be starting day 4 of our training. So today we'll be discussing about advanced logic, data migration, and programmability. Now, when it comes to, the objective for today is basically controlling query logic and showing you how conditions work, and also I'll also show you how to create a safe backup or move large data sets, and then handling missing data and packaging queries into reusable objects. Okay, now let's start with uh, logic, math, and handling the unknown. Okay. Now, so at times, what happens if you are if you have written a line of code and then if you want to comment it out, you don't want to execute, as I have discussed earlier, you can use this double dash to comment it out, and that particular section of the code or that particular line, not section, that particular line will not execute. Now, if you want to execute, if you want to comment out an entire section, so at the beginning of the code, you have to use slash star, and at the end of the code, you have to use star slash. That way, you'll be able to execute only that, that portion which is within these two, within these comments. So basically, it will not execute. Okay, this is how basically you create multi-line comments, right? Now on top of it, no, if you want to add some operators, so just like your regular operations that you do, all mathematical operators will work in SQL as well. Okay, so like for example, plus, minus, and then multiplication, divisions, percentile, all these mathematical operations are pretty much same that you have in any other programming language. Okay, now if you want to combine text, okay, so if I'm using this plus symbol between two texts, so basically it will act as a it will merge the two texts. It will act as a concatenation, and then it will merge the two text into single text. Okay, now, just like any other programming language, we also have, if you want to provide conditions, okay, you can provide using case statements. Okay, so just like you have if then else, so we can do that using case. Okay, now in SQL, basically I had shown, if you remember, couple of sessions, even last session or the previous session, I had also shown how null works. So basically, you don't use equal to null rather than using equal to null. So you use is null. Okay. Apart from is null, you can also use coalesce. Okay. And to understand the difference, if you're using is null, so it will identify all the null rows and then filter out. And if you're using coalesce, it will give you, or it will return all the non-null values. Okay. Now, apart from that, we can also write something, or we can also use a clause called select into, which will basically copy data from one table and insert it into a new table. I will show that example. And then insert into, we have already done, but here in today's session, we will do insert into select. Like if you want to write multiple lines in a table, so we can use insert into and then select star from a table or whatever it is. We can directly move multiple lines from one table into another table, or copy lines, multiple records from one table, and then just paste it or insert it into another table. Okay, now if we talk about stored procedures, so stored procedures are basically I have mentioned here, is a wrapper functionality that is available. So basically, a prepared SQL code that you can save, or multiple, if you want to execute multiple lines in one shot, you can do using stored procedures. Or else, if you want to improve the performance, also at times, stored procedure can also act very well in when it comes to performance optimization. So rather than running a query, if you use stored procedures, There are ways of doing it. Okay, so you'll see like the performance gets little bit better. On top of it, stored procedures are used. I mean, before the UI ETLs that we are using right now. I mean, these days where it is just drag and drop. So earlier we used to use stored procedures where we had the source data, we cleaned the source data using a stored procedure, and then dumped the data in the final destination using stored procedures. Okay. Now, let's go ahead and look at our examples. Okay. Now, for today's demo, again, I'll be using the same schools underscore demo database, and I'll be using similar data. Okay. So let's get started. Okay. Now, the very first example is since we are already in schools underscore demo, so I'll not have to use this statement, which is use schools underscore demo, and then I use go. So basically I can use this if I'm not in a particular database, but if you can see, I'm already in the server and that particular server and database, so I don't have to use it, but still I will go ahead and execute this. Okay, now okay, this is a very good practice before you start your code to point out or point your script to that particular database that you are targeting, so that nothing goes wrong. And since we are doing today a lot of write backs, okay, so it's very important to target that particular database and those particular tables. So at times what happens, the users or the coders, when they are writing something on SQL, so if they are not pointing, maybe they're doing something on the dev environment, right? But yeah, there is an issue in the prod. They were checking in the prod, and rather than writing or testing out in the dev environment, they ran the code in prod. So what will happen? Entire data will be overwritten, or some records might get deleted. So to avoid that, it's better we use database name go, so that we are in that particular database. Okay. Now, so comments, as I told you, it's fairly simple. So select order ID, amount, and then I will add an operator here. Okay, I will add amount, and then I'll just multiply it with 10. Okay, and then I will again go ahead and divide it by 100. So it follows the same principle of BODMAS, if you are aware of it. So basically you can just use that. Okay. Now, since I'm using this in bracket, so this operation will come first, and then it will be the division. Okay. So I will use as estimated tax. Okay. Now here I want to describe something, what this calculation represents. Okay. I can describe it using this comment. So I'll comment out and I'll use whatever I want. For now, I'll just use arithmetic operators. Okay. And since I have commented before this arithmetic operators, so this part will not be executed, and then it will straight away go to the next line. Okay. Now next we'll use amount, total, okay, total amount with tax, and finally from orders. Okay. Now if we go ahead and execute this, So this is what we are getting. Okay. So this is what we're getting. So first column order ID, then amount, which is basically the actual amount, then amount multiplied by 100 and then divided by 100. So this one I'll fix it a bit. Multiplied by 10 and divided by 100 as estimated tax, and amount plus amount multiplied by 10 and divided by 100 as total with tax, okay, from orders. Okay, now if I want to execute this again, okay, I am getting this value. Now, if you see the last value, the last two values, the decimals are going way off. So if I want to round off, I can also use round. Two decimal places. Okay, so now if I go ahead and execute, okay. Okay. So round. Second. 10 comma 2. So it's going that way. So I mean it's just matter of rounding off. Um, Yeah, so I don't want to go too much into it. So basically just give it a try. So there's a function called round. You can use this function and it's a built-in function. Maybe that's the syntax expression, then precision in digits. So somewhere this rounding of or brackets thing is missing. So let me just try one last time. For some reason, it's still not working. Okay, well, I'll not go much deep into it, but yeah, basically you can try it from your end. Okay, now, okay, next, or else maybe once we finish, I can come back to this one. Now, next is the case statement. Okay, so if I want to write a condition, okay, I want to provide a condition. Basically, I want to categorize order sizes dynamically. Okay, then like which particular order size is high value and which is low value and medium value. Okay, I can use a case statement. So it will be select order ID, then amount. Now I can start writing the case statement. Okay, so you can see that. So here I can, when amount is greater than equal to 1000, then I would say it is called as high value. When amount is, so now I'll add between 200. then medium, else low value. Okay, medium value, else low value. And then I want to also provide as a category. So case, condition, else, then end, and then I have to also provide like an alias name, right? So I will create the alias name as order category. Okay, and then from the table, from orders, and then finally I want to also order by amount, and I want to keep it as descending. Okay, so now if I go ahead and execute, okay, so now you see, so yeah, whichever is high value, it has been defined as high value, more than 1,000, more than equal to 1,000, then medium value and low value. Okay, so the order amount has been defined as this accordingly. Okay, so yeah, so basically, again, this is the way I can write the case statement. So syntax is case, when, condition. If you have multiple conditions, write using when. You don't have to end it with anything. Then else, final value. Then you have to provide end, and then the alias name, whatever you want as alias name for this particular column. I created order category, right? So order category from orders, and then finally I did order by on amount. Okay. Now, next example is null. Okay. So, if I want to recall from day three, so if you remember, John Doe has no manager, right? So the manager ID is null for John Doe. Okay. So from the employees table. So what I'll do, if we try to concatenate his name with his manager's ID, it breaks without is null. Okay. Now, let me just show you. Employee name, and then I just want to concatenate a text. I will say reports to manager ID. Okay. And then, as I told you, I can use something like this. And then I can use this function called as cast. Okay, cast or cast, whatever you want to call it. Okay, this basically helps me convert the data type of a particular field, okay, or column. So it will not convert permanently, but yes, on the DDL part, it will convert. Okay, like for example, if there is a field by default or in the source, it is in varchar, but it is a date field, and if I try to apply date filter on it, it will not work unless I concatenate and convert this to a date field. Okay, or could be like a varchar, but it has numbers, and I want to find out. Maybe I don't want to do a mathematical operation on that particular field. So first I have to concatenate, and only then I'll be able to apply a mathematical function or arithmetic function on top of it. Okay. Now, so I'll use cast. Okay, is null. Manager ID. Okay. reporting line manager from employees. Okay. So now if I go ahead and execute, second, I left it here. Okay, so now you see, so John Doe reports to 0. Okay, because I've mentioned if is null manager ID 0 as varchar 10, and then as reporting line manager employees. Okay, now apart from that, let me show you how coalesce works. Okay, now first I have to use select customer name, and now I want to use this. Here I'll use the field contact name, city, now see what this will give. Okay, now so this is basically useful if you check multiple lines. For example, if you are checking cell phone, if null, check home, if null, then check home phone. If null, then check email. Okay, so it finds the first non-null value. Okay, now next example, let's go into next example. Okay, now this example will look into select into. The objective here is to create a brand new table called, we call it something as customers backup. Okay, let's call it as customers backup 2026, and copy everything over that particular table. Okay, now if you want to do it, we do select star. Okay, this new table name, where we want to pick the values from customers. Okay, select star into customers backup 2026, and then I want from customers. So now if we go ahead and execute, okay, 7 rows effect. So now if we go and see, refresh. Okay, so customers backup 2026 has been created. So if I want to execute, select stars from select star from customer backup. So now you see the data that was there in customers, I was able to copy entire all the records into it. Now, if you want to add filters and all, you can also apply a where condition and then filter out specific rows and then copy into it. Okay, like for example, if you want to create a separate table for Mexico, okay, so you can write a where condition where city is equal to Mexico. To give you an example, okay. So now if we go ahead and apply, select star. Okay. So whatever records we want to copy, we want to copy it. Okay. Now, another approach is, another use case for copying is we can also insert into a table. So this one of the use cases is basically to archive your data. Like you have a lot of transactional data, and then you want to archive your data into a different backup table or something like this, or archive table. You can use this approach. So basically, in this example, so I want, first we manually will create an empty archive table with the exact same structure. Okay, so we will create orders table. So one second, let me just see if I have orders table. That's fine. I'll just create orders table. Okay, so we have order ID. I will maintain order ID as int, and then I use this as primary key. Then customer ID as integer, employee ID integer, order date as date time is fine, and then decimal I will maintain as 10 and 20. Okay, here I'll just maintain it as date. Okay, so now if I go ahead and execute, okay, done. Now, if I want to copy orders older than 2025, uh, 1005 into existing archive table, I can do that. So first I have to write a select. So select order ID, customer ID, employee ID, order date, amount, okay, from orders, where date is less than, I would say, 2025 dash 10 dash 5. Okay, I want, yeah, okay, I want this state. Records from this state. So let me first check the records. Okay, so these 3 records. I want to write all these 3 records into my orders archive table. So I can use insert into, and it's not like, see, in the first case, insert into, you have to write everything column wise, but here you can decide like which columns you want to use to insert. So if I'm just using order ID and in select I have order ID, it will insert only in that particular column. So you can target specific columns as well. Okay, so here I will do insert into orders archive, order ID, customer ID, employee ID, and then I'm having select. Okay, now it's good. So now if I go ahead and execute, okay, and let me test it. So orders archive, select star from orders archive. Okay, so now orders archive, I'm getting all these records in order archive. Only those that are select this thing. Okay, now okay. Now next we will look at stored procedures. Okay, as I said, stored procedure is basically a wrapper functionality which can be used to create reusable scripts. Okay, maybe I'm having 5 lines of codes. Okay, so every time I don't have to write all these 5 lines. To give you an example, I have a query. I'll say select employee name, then total orders, total sales from employee, and then I want to create a left join on orders, and then I want to take up the primary key, and I also displayed e.employee ID. Now I want to apply a condition where e dot employee ID is equal to now I want I mean employee ID for now I'll just use 1. Okay, and then I want to group by employee name. Okay, now if I go ahead and execute this, okay, so this is what we are getting, right? I'll not use 1, maybe I'll use 3. Okay, okay, this is what I'm getting. Now if I want to keep or make this entire query wrapped into one query, I can do something like this. I can create procedure, get employee performance. I'll just say 1 for now. Okay, and then as begin. So this is the syntax. Okay, create procedure as begin, and then we have the select clause. Okay, and finally end, and then we can use the okay. So now let me just create the procedure 1 second. To remove this part. Okay, now, okay. So create procedure. So on purpose, I've given the name one. As begin, select all these three columns, and from employees, he looks good. Okay. Now, always whenever I create a procedure, it will, create procedure name as, then begin, then your statement, and after the statement, end, and then you will, then you can do a go. Okay. Okay, so now you see the performance has been successfully created. Sorry, the procedure has been successfully created. Now, next time, if I want to execute the entire code, I don't have to write the code again and again. Okay, I can just execute it in a single line. So if I just do execute get employer performance, okay, it will just give me the same result, no matter how many times I'm executing. Okay, now I can also make the values dynamic. Okay, so to do that, first I have to declare a variable. Okay, so now before as, this is where I can declare a variable. You can declare even multiple variables as well. So you can declare integer. Now I want to use this variable rather than using a static value. I can use this variable that I've created. Okay. Now I will change the name of the procedure. Okay. Get employee performance, and then I will create a new procedure. So now if I go ahead and again I execute. Okay. So now the procedure has been created. Now next what I'll do, I'll again execute the same procedure. Okay. But this time I will pass the variable empid equal to 3. So now if I go ahead and execute this one, I'll get 3. Next time, if I go ahead and execute this, 5, Sarah Wilson. Okay, John Doe. So by using a stored procedure, I can wrap these multiple lines into a single line, and then this get employee performance will is nothing but this entire query. So with this, we will end today's session. Thank you so much for watching this video.